This is going to be 4.3 and 4.4. We're going to combine both of these sections into one. The reason is because both of them are going to be factoring. So I didn't see any sense of us keeping it separate. One is going to be factoring with a 1 in front of our x squared, and the other one is factoring with a number in front of our x squared. But the process is really the same for both of them. So I have to preface this with saying that in Algebra 2, factoring is one of the most important skills for you to have. It is used when you move on to a new class. It is something that you need to master, so we definitely want to spend a little bit of time here making sure that you understand this. So let's get right into some vocabulary, mainly because, not because this vocabulary is really important, but more because when you hear people say things like binomial, monomial, trinomial, you really should just know what they are so that way you don't get confused for no reason. So monomial is our first one. M-O-N-O-M-I-A-L is an expression that is either a number, variable, or the product of a number and one or more variables. Basically, it's a single term. A binomial is the sum or difference of two monomials, x plus 5, binomial. Okay, a trinomial, I'm guessing you could figure that out, is the sum of three monomials or difference. And then if you recall back from the first section, we have a quadratic equation. Before it was function, now it's equation. Pretty much the same thing. Is an equation that can be written in the form ax squared plus bx plus c when a does not equal 0. This next one might be new to you. The roots of an equation are the solutions of the equation. So you will hear a lot of different terms, and you might want to jot these down. Roots, zeros, x-intercepts, and solutions. All four of these mean the exact same thing. Very important to know that. Roots are the solutions of a quadratic. Zeros are the solutions of a quadratic. X-intercepts are the solutions of a quadratic. Okay, and then the last thing, zeros. The zeros of a function are the points where the function crosses the x-axis. All of these are the same idea. So when we get into factoring, what the idea of this is we are trying to take a quadratic equation that is in standard form, and we are trying to break it down into what we call factors. We call them binomials. So we're typically trying to break it down into two binomials so it's easier for us to solve. So what I first want to start out with is the special factoring patterns that we have. This is really important for you to know because it makes factoring a whole lot easier. The first one we talk about is the difference of two squares. And what that means is if you have two things without a middle term, no x term in the middle, typically you want to look to see if you can factor it using the difference of two squares. So for example, x squared minus 4. The reason why I know that this is a difference of two squares is because you can take the square root of 4. 4 is a perfect square. And that will always be the plus or minus square root of that number. So x squared minus 4 is just x plus 2, x minus 2. And then you have the perfect square trinomial, and this is where you have something that can be broken down into the same exact factor twice. So like, for example, we have x squared plus 6x plus 9. Well, the square root of 9 is 3, and 3 plus 3 is 6. So you have the same exact term twice. So you say x plus 3 squared will equal this. For the difference one, it's the same idea. We know the square root of 4 is 2, and negative 2 plus negative 2 is negative 4. So let's look at a couple of these examples down here. Basically what we're looking at is we have x squared minus 81. The square root of 81 is 9. Because we have a minus, what's happening is we get x plus 9 and x minus 9. The reason why this works is when you FOIL this, you will get a positive 9x in the middle term, and you'll get a negative 9x on the outer term, so the middle term cancels out. That's why we don't have an x term. For the second one, again, you look at 16. Well, the square root of 16 is 4. 4 plus 4 is 8. Therefore, we can write this out as x plus 4 and x plus 4, which is the same as saying x plus 4 squared. This third one right here, We have x squared minus 6x plus 9. Square root of 9 is 3. Negative 3 and negative 3 is negative 6. So we can just simply say this is x minus 3. X minus 3. Same thing as saying x minus 3 squared. So those are our special products. If you go through and factor in the way that I'm about to show you how to factor, that is fine. You can do that. I'm just trying to show you a couple of simpler methods on factoring equations that look like this or this. Okay, moving on. Why do we factor? Well, we factor because we're usually solving. We're trying to find where a quadratic is typically equal to 0. So what we are going to do is we're going to factor these equations. So you see this x squared minus 2x minus 15 will factor to look like x minus 5 and x plus 3. And we'll get into how to do that in a second here. But the idea of this is once we get our factors, we need to understand what to do. We want these to equal 0. So if you know anything about the zero product property, it says that anything multiplied by 0 equals 0. So if this portion equals 0, then the whole thing equals 0. 0 times anything is 0. If this whole portion equals 0, it's equal to 0. Something times 0 equals 0. So what we can do is once we get our binomials in place, we can set each one of them equal to 0. X minus 5 equals 0 will be x equals 5. 5 minus 5 is 0. X plus 3 equals 0 will be x equals negative 3. Negative 3 plus 3 equals 0. So our roots, or solutions, or zeros, however you want to call it, are 5 and negative 3. So let's get into how to actually factor. So we have x squared minus 3x plus 2. What I'm going to do is I'm going to teach you just a way that you need to think about factoring. If you know how to FOIL, then factoring should be pretty easy. And the way you're going to look at this is I always set up a chart. My first term, x squared term, and my very last term. And what I'm going to do is I'm going to write all of the possible factors, the numbers that can be multiplied together to get the coefficient that's in front, or to get the number here. So 1x squared, that's really easy. We're going to do 1 and 1. And it will always be 1 and 1 if it's just x squared. Then we do our 2. The factors of 2 can be 1 and 2, or negative 1 and negative 2. And basically factoring comes down to, once you do more of it, you'll start to be able to figure out which ones are going to be right and which ones are going to be wrong. But it really is a trial and error. We're not going to go through any method, because the methods that people teach you, you forget. And you need to understand how to factor all the time, anytime, without trying to memorize some weird method. So this first one, we have all of our possibilities. And what we do is we just try it. We do x plus 1, x plus 2, and then we FOIL that out to see if it works. First times first is x squared. Last is, or outer, x times 2 is 2x. Inner, 1 times x is 1x. Last, 1 times 2 is 2. So you see we end up with x squared plus 3x plus 2, which is not what we want. We need it minus 3x. So clearly, we need to rethink this. And I know that you already have it written down, so you can write it off to the side. So we're done. This is not working. So now we have to do the next one. X minus 1, x minus 2, and then you check it. X squared minus 2x minus 1x plus 2. And that's exactly what we're looking for. So now, because we know that this is the good factor, we can now solve each one of these. When is x minus 1 equal to 0? At x equals 1. When is x minus 2 equals 0? At x equals 2. So there's our two solutions. Okay, moving over to the next one. Same idea. Except negative 40 is going to have quite a bit more choices. So I'm going to put that up here. So we have x squared right here, which is going to be 1x and 1x. That's easy. Don't forget the negative here. Negative 40, very, very important you have the negative. Now, when you're doing these, I always start at the middle factors, the two numbers that are closest together. So negative 40, I know that negative 8 and 5 go into that. And that means we also need a 5 and a positive 8 and a negative 5. Then I go to 4 and negative 10, negative 4 and positive 10. And then the next one would be 2 and 20. So 2 and negative 20, negative 2, positive 20. And then we have our 1. 1 and negative 40, and negative 1 and positive 40. And like I said, I always start with the ones that are closest to the middle and test those first. So the first one that I'll do is x minus 8 and x plus 5. X squared plus 5x minus 8x minus 40. And you should be able to see from the middle that we're going to get a negative 3x in the middle, and we need a positive. So right away, as soon as you see that it's negative instead of positive, just flip the signs. Put a plus here, put a minus there, and you know that that will work every single time. So x plus 8, x minus 5 is going to work. And again, I know that it's going to work just by trial by error, but knowing that if you flip the signs, it's just going to flip the middle term. So this was negative 3x, so this is going to be a positive 3x, which is exactly what we're looking for. Keep in mind, when you try these, your first and last term, x squared and negative 40, should be the same every single time, no matter what you try. We're just trying to test to see what middle term works. So therefore, our x values here are negative 8 and x equals 5. Okay, moving on. Now we're going to get into terms where we have something in front of our x squared or z squared. So really important here, the first thing you always do, always, is look for a common factor. Is there something that goes into all three numbers or both or several terms? In this case, we have 18, 36, and 16. For sure, 2 goes into it. You're looking for the largest number that goes into all three of them, and that's 2. So I bring a 2 out, and I divide every term by 2. 18 divided by 2 is 9, so we have 9z squared. 36 divided by 2 is 18, so we have 18z. 16 divided by 2 is 8, so we have 8. And now we go through and try and factor this. So we write out our chart again. And I know this can be very tedious. Sorry about that. This can be very tedious, but we need to make sure we do it. So 9z squared will be, we have 3z and 3z, or we have 1z and 9z. Our 8 can be 4 and 2, and it could also be 1 and 8. Now, there's a reason why I'm not doing the negatives here. If everything in your trinomial is positive, you will never have negative terms. It's impossible. It can't work that way. So I'm just going to put the positive terms down right here. So let's test this. We have 2 times 3z plus 4, and then 3z plus 2. And now let's test this. Leave the 2 on the outside. We know the 2 is good. So we go 9z squared plus 6z plus 12z plus 8. 6 plus 12 is 18, which is exactly what we're looking for. So we know that this right here is the correct factor. Moving on to the next one. We have 6u squared minus 24u. We're going to factor out our 6 because 6 is common, but we also have a u on both terms. So I'm going to bring a 6u out to the outside. What are we left with on the inside? We have 1u left over. How do I know that? 6u times u is 6u squared. Minus, and 6u goes into 24u 4 times. That is factored. There's nothing else there to factor because we don't have any squareds left. So important to understand that. Okay, and then this last one, or the last two, we have 11q squared minus 44 equals 0. So now we're solving the equation. First thing, common factor is 11 off of both terms. So we have 11, and then we're left with a q squared minus 4 on the inside. This one is not done, and the reason why this one's not done is because we have a squared. If you notice, this is a difference of squares. So we should have 11, and then we should have q minus 2 and q plus 2 equals 0. This 11 is meaningless for solving this because this will never be 0. So we have two solutions here. Q equals 2 and q equals negative 2. There's our two solutions. Okay, I want you to try this one on your own. See where you get with it, factoring it and solving it, and then we'll see how you do. So in this one, again, if you look to see if you could do a common factor right at the beginning, there's not a common number that goes into all three of those, so there's nothing for us to do. So we set up our chart with 4p squared and 9. 2p, 2p, 1p, 4p, 3 and 3, 1 and 9. No negatives because the entire thing is positive. Set up our factors. We realize 2p plus 3 works. We go through and we see that 2p plus 3, we solve that for 0 and get negative 3 halves. So look over that and make sure you ask questions in class.